Hello guys, welcome back into this new video in our YouTube channel. So in today's video, we're going to be solving an interesting part of the June 2024 pure math mechanics. So the equation with the parametric equation of a curve are given by x equals 1 plus t, y equals 2 plus 1 over t, where t is given from 0 is a parameter. Question 1. Show that an equation of a normal to the curve at the point where t equals 2 is 8x minus 2y minus 19 equals 0. The next question says, find the value of t at the point where this normal meets the curve again. Okay, as we all know, I've typed the solution already, so I'm just going to be explaining as we proceed. So let's get started. Solution. We have x is equals to 1 plus t and y is equals to 2 plus 1 over t. And we are asked to look for the equation of a normal. We know that for the equation of a normal, what we need is the respective point of y and x and the gradient of the normal. So this is the general formula. Thus we have y minus y0 is equals to mn into x minus x0, where mn is the gradient of the normal and mt the gradient of the tangent, that is the tangential gradient. Now y0 and x0 are the corresponding values of y and x when t equals to 2. And to have them, I'll just come and substitute t equals 2 in these parametric equations. Okay, let us proceed. Since the normal and the tangential line are perpendicular, it will mean that mn is equals to negative 1 over mt. Generally, two lines are said to be perpendicular when the product of their gradient equals to negative 1. That's mn dot mt is equals to negative 1. And from there, if you want to make mn a subject formula, you realize mn will be equals to negative 1 divided by mt. Now, to have mn, what do? We need to have mt first of all. And to have mt, generally mt is simply dy on the x. And to have dy on the x, we have to differentiate this parametric equation. So, but unfortunately, they have been given types of parameters, so we're going to differentiate each of them before combining. So, the x on the t will be equals to 1 because when you differentiate 1 plus t with respect to t, when you differentiate 1, you have 0. And when you differentiate t, you have 1. And dy on the t, now same thing here. When you differentiate 2, you have 0. And when you differentiate negative 1 divided by t, you have negative 1 on t squared. Now, from chain rule, you realize that you have dy on the x is equals to dy dt times 1 on the x on the t, which is equals to mt, as the tangential gradient. But we know that the x on the t is 1. So from there now, dy on the x will be equals to dy on the t. Now at the point where t is equals to 2, you realize that when you substitute t equals 2 on mt, you realize that mt will be equals to negative 1 divided by 2 squared, because actually dy on the t was negative 1 divided by t squared. So when you replace the value of t with so when you replace t with 2, you have mt to be equals to negative 1 divided by 2 squared. And from there now, mt will be equals to negative 1 quarter. Now mn, we found that mn was given to be negative 1. Mn was negative 1 on mt. So mn will be equals to negative 1 divided by negative 1 quarter. From there now, mn will be equals to 4. Now we are looking for the corresponding values of x0 and y0. x0 is going to be 1 plus 2, and y0 will be 2 plus 1 half. We all know how we got these values. So x0 will be 3 and y0 will be 2.5. Now equation of normal. So we are just replacing all our values. That's y minus y0 is equals to mn into x minus x0. That's y minus 512 is equals to 4 into x minus 3. So if you do that correctly, we're going to have 2y minus 5 is equals to 8x minus 24. From there now, we simplify it correctly. I'm going to have 8x minus 2y minus 19 equals 0. That's as required, because that's what we have to show. Yes, that's what we have to show. Okay, now question 2 says we should find the value of t when the normal line meet the curve again. Okay, actually for us to look for the value of t, the idea here is that we are going to take these parametric equations, and we are going to substitute it here in this equation of normal. So we are going to take the corresponding values of x and y and substitute it here, and we're going to have an equation in t. So that said, you do that correctly. This is what we're going to have. We have 8 into 1 plus t minus 2 into 2 plus 1 over t and 19 equals 0. So we have 8 plus 8t minus 4 minus 2 on t minus 19 equals 0. 8t minus 15 minus 2 on t equals 0. We multiply also by t, we're going to have 8t squared minus 15t minus 2 equals 0. So we realize that this is a quadratic in t, with the coefficient of a to be 8, that of b to be negative 15, and the constant term c negative 2. So if we are applying the quadratic formula, we're going to have t be equals to negative b plus or minus the square root of b squared minus 4ac on 2a. So if you substitute all these values correctly, we're going to have t be equals to negative 0.125, or t will be equals to 2. So basically this is what we're supposed to do. Now these are some bonus questions, or some interesting bonus questions. They said find the point where the normal meet the curve. That's question 1. Question 2. Write down the equation of the tangent at the point where t equals 2. Then question 3. And hence take the point where the tangent line meets the curve. Okay, as I said, these are just some bonus questions. Yes, because they were not included, so that's why I wrote the bonus questions. Okay, now when t equals to negative 0.125, you realize that the corresponding values of x will be 1 plus negative 0.125. We are just substituting it in the parametric equation. Yeah, this is where we are substituting all these values. When t equals to negative 0.125, you have x to be 1 plus negative this, and we have y to be 2 plus 1 divided by negative this. Okay, that's it. We're going to have our x to be equals to this and our y to be equals to negative 6. Meaning that when t equals to negative 0.125, the point where the line, that's when the normal line meet the curve, will be at the point 0.875 comma negative 6. Yeah, that's the point. That's the first point. On the second point, when t equals 2, when we substitute, we're going to have x equals to 3 and y equals to 5 on 2. So this is the second point where the normal line meet the curve at the point 3, 2.5. Okay, now the next question says we look for the tangential equation. It's the same thing with the equation of the normal. So we have y minus y0 is equals to mt into x minus a0. Since they said at the point where t equals 2, it will mean that the values of y0 and x0 will not change. They will be the same thing. And mt equally will not change, because we found mt was this is the value of MTA. That was negative 1/4. So if you substitute all those values, you're going to have the equation of the tangential equation to be x plus 4y minus 5 equals 0. Now the next question says we should look for the point where the tangent line meets the curve. Okay, basically there are two ways of doing this. It is either you take these parametric equations and substitute in the tangential line, or you can decide and eliminate these parameters and eliminate this parameter t. That's you make t the subject formula on either of the equation and substitute on the other one. So that's what I did. From equation 1 we have x is equals to 1 plus t. You mean that t will be equals to x minus 1. So when you take x minus 1 and substitute here in equation 2, you have that y will be equals to 2 plus 1 divided by x minus 1. And if you simplify correctly, you're going to have that the value of y will be equals to 4. The value of y will be equal to 2x minus 1 divided by x minus 1. So when we substitute it here in the tangential equation, we have x plus 4 into 2x minus 1 divided by x minus 1 minus 5 equals 0. From there now we're going to have x squared plus 2x plus 1 equals 0. This is still another quadratic equation to solve for x. If you do that correctly, factors down, when you multiply you have AC and you add you have B. That's 1 and 1. 1 times 1 is 1 and 1 plus 1 is 2. So the values of x will be equals to negative 1. Now when x equals negative 1, you just come and substitute it here. You have negative 1 plus 4y minus 5 equals 0. From there now you have your y will be equals to 3 on the 2. So basically this is the point. That's the point. Negative 1, 1.5 is the point where when the tangential line meets the curve. Okay, that's it. I'm going to make a video where I'll be explaining this graphically. Yes. So thank you guys for watching, and see you in the next tutorial.